I am going to show you examples right now, and I'm going to tell you what function to use. When you complete your lab and when you complete your exams, you will have to decide what function to use based on the question. So this question states, write an Excel formula in cell D2 to calculate the payment for a loan amount of $15,000 at 9% interest rate for a period of 5 years. Assume the loan is compounded monthly. So we're going to use the payment function. We have the syntax of the payment function shown, and let's plug in the values. Well, the interest rate, or the rate argument. The interest rate is 9%. I told you for this argument, you always take the interest rate and divide it by the number of compounding periods. In this case, it's monthly, so it's 0.09 divided by 12. The next argument is the number of periods, or the NPER. I told you for this argument, you take the number of years and you multiply it by the number of compounding periods, which is 12. 5 times 12. The next argument is the present value argument, or PV. The present value for this loan is $15,000. That is money that is coming to us, so we do not put a negative number in front of it. The future value argument is a 0 because we assume that we will pay this loan off at the end of 5 years. And the type argument is 0 because we will assume that payments will always be made at the end of the compounding period. On the right-hand side, because I have 2 zeros at the end, I can end my argument list with the 15,000. Now, sometimes you will hard code these, but many times I'm going to have you set up a spreadsheet and then type in cell references. So if you notice here, I have my spreadsheet set up very nicely. So I can plug in any values, change any numbers, and put the function in. So in this case, I am calculating, or I want to find the payments per period, which is in cell D2. So I have the payment function, and now I'm just plugging in the cell references. Notice cell D2 is in red with parentheses. In this case, I've formatted this value, or these values, to display as red and with parentheses if it's a negative number. So if we type in that function, we will receive the value $311.38. That's our payment. And payments are usually denoted as negative, so that's why I have that as a negative value. I also want you to notice the future value cell, F2. It has a hyphen in it. Remember, if we are formatting this in accounting, then a hyphen means that there's a 0 displaying in that cell, or there's 0 in that cell. Let's do an example of the NPER function, which returns the number of payment periods. Write an Excel formula in cell B2 to determine how many years it will take to save $12,000 if you put $10,000 into a savings account paying 4% annual interest rate compounded quarterly. There's the syntax of the function. Let's plug in the arguments. The rate argument, the interest rate is 4%. It's compounded quarterly, so for the rate argument, we always take the interest rate and divide it by the compounding periods. The payment, we're not going to put anything else into the savings account, so it'll be 0. The present value is $10,000, so we will put negative $10,000 because even though we're putting it into a savings account, it's not going to be accessible to us, so Excel assumes it's a negative number. And the future value is $12,000. That's what we want to have at the end of this transaction. And then finally, the type is 0 because that is, we will always have the type at the end of the payment period, so that's a 0, or payments will be made at the end of the period. And then we divide that whole function by the number of compounding periods, which is quarterly. Again, to the right, you see where I have a placeholder for the 0, and I left the 0 off as the last argument. So in cell B2, when I type the function in, I get 5 years. Notice in cell E2, or in the function itself, the argument E2, it should be a negative number because I have negative $10,000. I didn't put negative E2 here. The reason why I didn't put a negative in front of the E2 is because I already have the present value as a negative number in the cell reference itself. Another example, the rate function. It returns the rate per period. Write an Excel formula in cell A2 to calculate the annual interest rate of a new Chevy Cruze. The cost of the car is $18,999, and you will put down $2,000. You will pay $350 per month for 5 years, and its annual interest rate is compounded monthly. There's the rate function and the arguments. Let's plug in the values. 5 years times 12, NPER argument. You always take the years and multiply it by the number of compounding periods. The payment argument, negative $350, because we are going to pay $350. The present value, $16,999. The cost of the car is $18,999, but we're putting down $2,000, so we're only going to finance $16,999, and that's money that's coming to us, so it's a positive number. The future value is 0, because we assume we will pay this off at the end of the 5 years, and the type is 0. You always take the entire rate function and multiply it by the number of compounding periods, which is 12. Again, on the right side, I've left out the comma 0, because if there are zeros at the end of the argument list, we do not have to include them. At the bottom, I have the cell references that I've plugged in, which is always the best way to complete this. And then we get our annual interest rate. Here's an example of the present value function that returns the present value of an investment. Write an Excel formula in cell E2 to determine how much money you will have to put into a CD now to have a $5,000 down payment on a car when you graduate in 2 years. The CD pays 3% annual interest rate compounded yearly. Okay, so we want to know, what do we have to put in now to get that $5,000 later? So we're going to use the present value. The interest rate is 3%. We always divide the interest rate by the number of compounding periods, which in this case is 1, so I didn't put it there. The NPER, the number of periods, is 2 years, and it should always be multiplied by the number of compounding periods, but that's a 1, so I didn't put it there. The payment, we're not putting anything else into that CD, so it's 0. $5,000 is the initial value, is the future value, is what we want to obtain at the end, and then the type is 0. Notice I have the other example with the placeholders and the zeros gone. And at the bottom, I have plugged in the values. And now you notice in cell E2 that I have to have $4,712.98 invested in order to get 2 years, to get $5,000 in 2 years. Example of the future value function, which returns the future value of an investment. Write an Excel formula in cell F2 to determine the value of a CD in 2 years. You plan on an initial investment of $5,000, and you will add an additional $50 per month. The CD pays an annual interest rate of 3% compounded monthly. Okay, so we have the interest rate of 3%. Compounding period is monthly, so 0.03 divided by 12 for the interest rate, or the rate, rate argument. The NPER argument, 2 years, multiplied by the compounding periods, which is 12. You're going to make a $50 payment, or you're going to put $50 into your CD every month, so it's negative 50. Your present value, you're putting in $5,000, so it's a negative 5,000, and the type is 0. And notice we have plugged in the values at the bottom, the arguments, and our answer in F2 is the future value of $6,543.93. Okay, here's another example. Write an Excel formula in cell G2 to calculate the monthly mortgage payment for a $100,000 home with a balloon payment of $10,000. The annual interest rate is 4% compounded monthly with a loan duration of 30 years. Note, a balloon payment is an amount due at the end of the loan and is indicated in the future value argument as a negative value. There's our payment function that we're putting in there. We're putting it in cell G2. Notice our future value argument is cell E2, because now we are going to owe $10,000 at the end of this transaction, because we are going to make a balloon payment at the end. And the balloon payment is just one large sum that we will pay at the end. 5 years ago, you won $75,000 on the game show, I Want to Win a Lot of Money. At that time, you invested the money in a CD that paid 6% per year, compounded monthly. Write a formula in cell C9 to determine true or false if you have enough to purchase a $100,000 house without financing. Okay, so now we need to go back to that 5 years in time and see what we'd have now. So we have to use the future value function. Notice the future value function. After we get that value, then we're using a logical operator greater than or equal to 100,000. If the future value function returns a value greater than or equal to $100,000, it will display a true. Otherwise, it will display a false. So you can also incorporate other functions within these financial functions, which is true of any function that we do.